Friends, let me formally introduce Anna Hoffman to you. She is from Microsoft and works with the Azure data team. She is a data and applied scientist and works a lot on democratizing AI for businesses. And Anna's such a honor and pleasure to host you. Today, Anna's session is going to be on Azure SQL, what to use when. And as I said in the beginning, that coincidentally, it has turned out to be a good timing, scheduling wise, to have this session right as the last session of the event, because you've heard so much about SQL 2019, the hybrid approach, migrations, Azure SQL, managed instance, VM and whatnot. And maybe Anna's session will be a good summary and will allow you to choose in between different scenarios. So great, coincidentally. So Anna, thank you so much for joining us. Over to you, Anna.
Great, thanks so much. And I am excited to be here. If you all just give me a moment to get my screen shared. But yeah, it's really exciting to be here, even though it's virtually. I've been wanting to take part in one of these Data Platform Geeks events for a while, so I'm glad I could finally make it work. Okay, let's see. Let me know, someone, if you can see my screen.
Yeah, I guess you have, yeah, I think it's coming up now.
There we go. You got it.
You got it?
Yes.
Okay. Let me just get everything moved around. No, that's not what you want to see. Sorry, folks. Okay, let's go ahead and get started. So welcome, thanks for sticking around. I know this is the last session of the conference. I guess I'm gonna move this because you guys can probably see that. I know this is the last session of the conference, so I'm glad you all stuck it out. Like Amit said, my name is Anna Hoffman, and I'm a data scientist / PM. As you're all familiar with, we wear a lot of different hats at any given time. But I'm on the Azure SQL team, and I have a few things I want to talk about today. First, I wanted to start with a brief Azure SQL history. It's very short. It won't be like your normal history lessons, but I think it's kind of interesting to see where we've started and see how the what to use when aspect of the journey has shifted over the years. And then we'll dive into what to use when. And I have a lot of different demos planned. It's not, they'll be interspersed throughout, so hopefully you won't get too bored of seeing slides. We got a lot of stuff planned, and a lot of these demos I'm doing for the first time for an audience, so hopefully they all go as planned. And Ree is moderating, so hopefully she'll be looking at the questions coming in, because I will most likely not be focused on them until at the end of each section maybe. But then I anticipate being done in much less time than 75 minutes. So hopefully we'll have lots of time for questions at the end or information about other things. And one other thing I'll add before we get started is that all of these demos are available for you to try out as well yourself. So this deck is posted with all the other decks for this conference, as well as on my GitHub page. And in the notes section for each demo, there's instructions on how to go about setting this up yourself. So hopefully that's something you can try later. Okay, so let's get started. So if we take a time traveling trip back in time to 2008, there was this conference that used to be every year called the Microsoft Professional Developers Conference, or PDC. And in PDC 2008, Ray Ozzie, who was our chief architect at the time, chief software architect at the time, he announced this thing called Windows Azure. And it was known as Project Red Dog. And ultimately, it had 5 main services. And what you see from this slide from 2008 is that SQL services, that's what Azure SQL was called originally, is front and center in this Azure platform. So I think that's an interesting thing to keep in mind, that this was, one of the core services in Azure when it started. And then in 2010, I found this from a blog post, and I know it's a lot of words, so don't feel like you need to read them, but I found this, and it was kind of saying, you know, what to use when with regards to Azure SQL Database. And just to skim a few important things, they said, unlike other editions of SQL Server, you do not need to provision hardware for, install, or patch. And Microsoft maintains that platform to you, as well as installation processes for scalability, high availability, and disaster recovery, because these are provided automatically by the service. And so to that, I'll say that, you know, it's not much different today. The PaaS services we're going to talk about offer all of these things and kind of give you that what to use when. What's changed is over the years, we've come a long way as a product, despite all the name changes, which is just kind of funny. There's also been new types of Azure SQL Database. In 2015, we did a big re-architecture of most of the service. And then you see in 2016, 2018, and really 2019, we got a lot more options available. And really, this isn't to make it confusing, but it's because we're listening to you all and we're listening to your feedback, and we're trying to improve our service and give you exactly what you need. So while there are a lot of options, just think about it from the perspective as we're just trying to give you the option or the ability to pick the best flavor for your use case. And in 2020, which isn't up here, but in 2020, we announced, and we're in the process of announcing, you'll see a lot more on our documentation soon, this idea of Azure SQL. And this is more of a family of all of these different services that we have that are related to SQL on the Azure platform. And we kind of group them into two pillars. So I'm going to talk about infrastructure as a service, or IaaS, which I think you're probably familiar with, as well as platform as a service, or PaaS. And these aren't specific to SQL. These are, you know, general cloud related terms. But what you'll see as we move from left to right, so IaaS to PaaS, you'll see that while it might seem like you are losing a certain level of control, what you're gaining is additional capabilities because it's built on that Azure backbone. So the first service I want to mention is SQL Server on Azure virtual machines. And the way to think about this is Azure manages the host and the hardware, but you're still responsible for managing the OS and the SQL Server. So this is very similar to running SQL Server on-prem, except Azure can give you some additional capabilities and benefits. Now, as we move into the PaaS services, the first one is Azure SQL Managed Instance. And the way I like to differentiate these is by thinking about the level of abstraction. So when we talk about Azure on virtual machines, the first item over there, that was talking about abstracting the hardware and the host. And here with Azure SQL Managed Instance, we're going to abstract one level higher, right? And we're also going to abstract the OS. And what that means is you still manage a SQL server, but you don't have to worry about the OS anymore. And you don't have to worry about updating anymore either, because now it's a platform as a service. And this is going to give you all the instance scoped features that you get with SQL Server. And finally, if we move all the way to the right, this is one more level of abstraction. So we're abstracting away the SQL Server. So you no longer have to manage the SQL Server. You really just get a database and you are ready to get going. And there are some other options available in here. And we're going to talk about these in depth. I just wanted to give kind of a brief overview. So the way we're going to go forward is we're going to look at each of these individually and look at the challenges that are posed that lead customers towards going towards these types of solutions. And then we'll take a look at the solutions and why there are solutions and some demos of some of the benefits along the way. Okay, so this first one is SQL Server on Azure virtual machines. And now some of the challenges that we see are, for example, the contract for the hardware is expiring, or a customer recently hit SQL Server 2008 end of support. Not so recently anymore, that was almost a year ago, but you'd be surprised how many customers are still running on SQL 2008 R2 or R2. But a lot of times, reasons like this, customers want to move to the cloud as fast as possible so they can start getting supported or modernizing again. Now, another common reason people have trouble moving to, say, managed instance or database is that they work with a third-party service or application that requires OS access. That's another common reason that we see people moving towards SQL Server on Azure VMs, because this is going to give you, all the versions as well as support for Windows, Linux, and containers. And this is really, it's just SQL Server, and we're going to give you some benefits as well. For example, we can give you extended security updates for a few years if you're moving from SQL Server 2008 or R2. And there's some automated things that you can configure to make your life easier, basically, with your SQL. And one customer story I like is Allscripts. And now Allscripts was able to move about 600 VMs to Azure in just a few weeks. And that's pretty amazing. And one of the things I like is that they moved to VMs, and then as they were getting used to the Azure platform, they started exploring Azure SQL Managed Instance, and ultimately they started to move some SQL servers to Managed Instance. And I think this is a good example of taking a phased approach to moving to Azure. So they took the easy step to get to SQL Server in a VM, and then could start slowly looking at workloads that could go to Managed Instance and get even more benefits from the service. So with SQL Server on Azure Virtual Machines, there are a lot of things related to it. I'm not going to spend a ton of time diving into these. The main reason I wanted to put this up here is that some of the resources I'm going to share are going to go into each of these in great detail. And two things I wanted to call out is, one is resource provider. And a lot of times what we find is folks will go and deploy an Azure virtual machine, and then they'll install SQL Server, because this is how you guys have been doing this for years and years and years. Now, what you have to do in order to get some of these Azure benefits is enable resource provider. So I just wanted to make sure I call that out, because you can get a lot of PaaS-like capabilities just by enabling resource provider. And this comes built in if you just deploy a SQL Server virtual machine in the portal, which I'll kind of show you what that looks like in just a few moments. Now, the other thing I wanted to call out is this advanced data security, which is in preview today. But this, again, is an example of how, since Azure is managing your service and your virtual machine, there are some added benefits that we can give you related to security. And that's really the one I want to start with from a demo perspective. So let me just switch over to my virtual machine. So this is a SQL virtual machine, and this is actually the resource in the portal on the SQL virtual machine. But what you can see is there are a few options around here for when I want to set up patching or backups. There are a lot of things I can configure. You can see I've only configured some of them. So automated patching or automated backup. So that's the SQL Server VM. And so what I could do is I could set up advanced data security. And so just to show you what that looks like is, in the security for the actual virtual machine, I can go to Security Center. And the way you can think about Security Center in Azure is it's kind of like this single pane of glass for you to see security over all of your resources. So not just SQL resources, but all of your resources. And so if I scroll down, I can see data and storage, and what you'll see is I can narrow down based on what I'm looking for. And I'm just going to look at my SQL virtual machines here, because that's what we're working with right now. And if I go into SQL VM, I can see the resource health and any recommendations. Now, these vulnerabilities that are being recommended is part of that advanced data security preview that I was talking about. So I can go into here, and it's basically running vulnerability assessments and assessing my server and then running a certain number of security checks, and it will even tell me how to mitigate these. But really what I wanted to call out is this idea of advanced threat protection. So this is something specific to Azure, and it's a very cool technology that allows us to detect things like SQL injection. And so I was able to set this up. I can show you all in my security alerts. Actually, I went ahead and set it up, but in security alerts, I can see these certain things. And again, I can go in and see all my incidents, but the one is this one, potential SQL injection. So this is a very thing you want to be made aware of if you can. So what you see here is I have 3 potential SQL injection attacks. And what this actually does is it sends me an email. And I did this morning because I wasn't sure how long it was going to take, but it actually triggered this. In less than a minute, I got an email about this, that there was a potential SQL injection on my SQL VM, and then I could go and explore that resource in the Azure Security Center. So I pulled that up. Let's see where it is. Well, we'll just click it. So when I pull this up, I'm then brought to that same view, here it is, of a potential SQL injection. So we see it says potential SQL injection, it's high, it attacked my SQL VM, and then I can see some information about it. So the first thing I notice is client principal name is Bob. So I don't know if you all know Bob Ward, but it seems like maybe Bob was trying to hack into my SQL Server. The reason it triggered this is because it was from an unknown application. So this is very interesting, and all of this can then tell me, okay, how do I remediate this, and what can I do now? So if I switch back over to my VM, just to give you a fun glimpse, I actually created this trigger. I created Bob, and fun fact, you know, Bob is a big football fan, big Dallas Cowboys fan. So I had to make him a Tennessee Titans fan, which is another football team in the US.
Oh, Anna. Sorry, that's brilliant. I'm not going to tell him though.
You can tell him, it's okay, go Titans. But yeah, so I created Bob, and then I basically set up a test, and I'm not going to get into it, but again, I show you how to do all this in the notes, how you can trigger these types of injection attacks potentially, and see what that looks like. And then, so that's SQL VM, and I wanted to show you, this was actually a little bit complicated to set up. Not complicated, it just took some time, right? What I had to do is I had to install this Microsoft monitoring agent on my virtual machine, because since it's SQL running in a virtual machine, we don't have the same type of access to it like in Azure PaaS service. So I had to set this up and connect it to a log analytics workspace, which then allowed me to do all the things that you saw today. Now, one of the benefits of PaaS versus IaaS, so moving towards something like SQL Database or Managed Instance, this is my SQL database, and in there's actually a whole blade for advanced data security. And this is really easy to set up. I can do it using completely the GUI or a few PowerShell commands, but I'm able to kind of see one pane of glass over my SQL database with regards to data discovery and classification, vulnerability assessment, and advanced threat protection, which is taking a few moments to load. But this is one of the benefits of moving to a PaaS service. You're able to see these, and you can see another attack that I triggered on that one. You're able to set up a lot of this stuff much easier without having to do things like install agents on your virtual machine, because all of that is abstracted away from you in a service like Managed Instance or SQL Database. So with that, I want to kind of bring us back, and this leads nicely into a discussion of IaaS versus PaaS. So IaaS, again, is this SQL Server running in a virtual machine, whereas PaaS is this abstracted OS or server, excuse me, that is kind of all built in for you. And that's one of the big differences, I think, is that with IaaS, like, yes, a lot of these things are built in, but with PaaS, with IaaS, a lot of these things are built in, but some of them require you to configure them. For example, to set up advanced data security took some time. There's some more control that you have, but with more control, you know, just like in Spider-Man, leads to more responsibility. So whereas in PaaS, all of these things can just be built in or can be triggered with a switch or can be set up very easily. So that's one of the big benefits of PaaS over IaaS. And the other thing I wanted to mention is the versionless aspect of a PaaS service. So if you move to SQL Server in a virtual machine, you're still going to have to update SQL Server when the next version comes out if that's something you want to do. With versionless SQL, which you get in a PaaS service, we're able to consistently roll out updates, and the responsibility is now on us to make sure we don't break you and to make sure we thoroughly test and make sure there are no regressions. So that responsibility has shifted to Microsoft, and we're doing this for millions of databases, so you can be sure that you know, there's a lot of things that go into making sure these things roll out smoothly. So that's kind of a big benefit of moving to PaaS, that you no longer have to worry about patching and updating and the headache of if something goes wrong. Like, all that responsibility kind of falls to us. And so with that, I wanted to move towards Azure SQL Managed Instance. And a lot of the challenges that we see that lead people to managed instance is that they want to move to the cloud, they want to move to a PaaS service, but potentially they need some of those instance scoped features, or there are still some management things that they want control over for whatever reason. So, you know, instance scope features means things like service broker, database mail, SQL Server agent, CLR, all those types of things are going to be in managed instance. And like I was saying, like, you get much more of the SQL Server surface area here. Almost 100% compatibility is the phrase we like to use. Compared to SQL Server. So this can make moving from, whether it's on-prem or in a virtual machine, to managed instance much easier, much more of a smooth transition without having to do a lot of re-architecting or restructuring of your applications. And you know what Bob always says is you get the best of SQL Server with the best of a managed service. So you know, there's a few other things on this slide, but managed instance is really your managed SQL Server in the cloud. And one example of this that I like is Komatsu, and they were able to easily move, you know, 1.5 terabytes of data very quickly. I think it was in a matter of days, and see great benefits. Almost immediately, they were able to see a 25% performance gain and as well as significant cost reduction. So there are definitely benefits towards moving to something like managed instance. Now, the next two demos that I have are focused around this idea of geo-replication and auto failover groups. And instead of just throwing you into this demo, I wanted to give kind of a brief overview of what they are and how they're different. So in auto failover groups, which is what you're going to see next, this is available in SQL Managed Instance and SQL Database. And this allows you to do things like failover groups and automatically failover without having to change any connection strings. So let's go ahead and take a look at that. Okay, so first I just wanted to show you this failover group that I deployed. I went ahead and deployed it. It just takes a little bit of time. I deployed it using PowerShell. It's very easy. Again, I'll share the PowerShell notebook that I used to get it all set up. But what I was basically able to do is set up a failover group between East US and East US 2. I know it's not the most interesting region split, but just working with the regions I have access to today. So what I have is I have my primary server sitting in East US and my disaster recovery server sitting in East US 2. And one of the interesting things about failover groups is what I mentioned about connection strings. So I'm just going to toggle this so you can see. But I have a read-write listener endpoint and a read-only listener endpoint. So what this means is when a failover occurs, because I'm connecting here, Azure's taking care of which one this one points to based on what the primary or the secondary is. So I don't have to manage that switching of the connection string. So that's really, really pretty cool. So I'm just going to turn this back on. This is actually a pretty cool trick. I can show you guys how to do this too later. Okay, so let's take a look at that. So let's see. Let me just get this set up. So don't worry about this app over here for just a second. This is the PowerShell notebook that I used to set this up. So you can see there are 6 commands before this one. And I'm not going to show you all of them just for time. But what you can see is I'm going to share how you can set this up on your servers or just for playing around. And then what I have on the right is an application. It's a pretty simple Java application. It's connected to both of those endpoints that I just showed you, the primary and the secondary readable. And what it does is it tries to do an insert on the primary, and then it tries to read that line that was inserted from the secondary. And it basically says if it was successful or if it failed. So right now you can see it's been going for a while and it's been pretty successful. So now I just wanted to show to confirm that our disaster recovery server is in the secondary state. So that's what we see there. And again, we can also see it here in the portal that the DR server is secondary. And just remember our primary right now is East US. Okay. So now what I'm going to do is I'm going to actually initiate a failover. And the way I do that is this command switch AZ SQL Database failover group. And I just specify to switch to the DR server. So what's happening right now is in the back end, Azure is failing over and switching these connections. So what we would anticipate to see is that the primary or the secondary may momentarily become unavailable. So that's what you're seeing here. The insert on the primary is failing because we're switching over those connections. And this should just take a few moments and then we'll be able to start reading again. And I want to take this opportunity to emphasize the importance when you're moving to anything in Azure to make sure you have retry logic in your application. Because retry logic is going to make sure that when this fails, your app doesn't fail. It just continues to attempt to connect. So what you can see is we just had one failed insert and read, and then we were back to being successful. And we can also see this command has finished running. So now we can check the status of our secondary server using the same command as above. And sure enough, it's now the primary. And in the Azure portal, we can see that that switch has happened as well. Like East US 2, the disaster recovery server is now the primary one. And no, we didn't have to change these connection strings in our app or anything like that. Similarly, I can fail back by using almost the same command, except now I'm saying, okay, fail back to the regular server, not the DR server. So it'll just go through and do a switch again. And this allows me to switch back and forth as needed pretty easily. So we're seeing it's failing, and it might fail for a few times and then it will succeed again. So this is a cool example of setting up failover groups. I did do this in single database as opposed to managed instance, but I could do it in either. I've done the same demo in both and it works very similarly. These commands for getting it set up are just slightly different. So we can see this has happened, and back in the portal, we've switched back to our primary being in East US. So hopefully that was a cool way to see something that was very complicated or time-consuming to set up on-prem or potentially even in a virtual machine is now very easy and has lots of benefits associated with it when we move to Azure. Okay. So next, I want to talk about Azure SQL Database. So we talked about managed instance, your managed SQL Server. It allows you to have access to instance scoped features. Now with Azure SQL Database, you're not going to get those instance scoped features, but there are a lot of customer challenges that Azure SQL Database can address. And we're going to talk through a bunch of them. I won't list them all right now, but a few might be that you want to run a multi-tenanted software as a service type of application. And for this, Elastic Pools, which is part of the SQL database deployment, is a really great solution for that. Also, today, we currently only have Hyperscale available in this SQL database deployment as opposed to Managed Instance or another deployment option, as well as the Serverless tier, which basically has allowed you to separate compute from storage and only pay for the compute when you need it. So there's a lot of benefits that come in and a lot of innovation that's happening here in the SQL database landscape. And additionally, not only is this the way to go if you want the highest SLA in Azure, but also if you want the industry highest SLA can be achieved here, as well as some price performance studies that we've done. And the example I would like to share about this is AccuWeather. And I like this example because AccuWeather didn't want to manage a server. They just wanted a database that had intelligent capabilities that they could leverage to start building intelligent apps. So they hooked up Azure SQL Database to Azure Machine Learning Services and were able to get started building new applications to help with sales and other customer-related prediction and models. And, ooh, that's not good. And then again, just to bring back up this idea of geo-replication versus auto failover groups, geo-replication is only available in Azure SQL Database today. And while auto failover groups might be the right solution for many scenarios, there are some situations where geo-replication is desirable, and this is only going to be available in Azure SQL Database. So with that, I want to show you how easy this can be to set up. Oh, let's see if I can access that tab. The Zoom is blocking me. Okay, loading. Okay, so this is another database. So this is a SQL database. We can see it's called AdventureWorks GP because it's in the general purpose service tier, and we're going to get to service tiers. We're pretty close to that. It's coming next, so just stay tuned. But what I can do on the left-hand side, you see I have this option for geo-replication. And this is pretty easy to set up. It's kind of funny. You just click around on a map, and before you know it, you know, you have readables in other regions. Of course, you want to be careful because there are implications here. But if I wanted to add one, let's say to Central US, I just have to select a target server. So I went ahead and pre-deployed just an empty logical server. So not a real SQL server. It's just a logical server that's used for SQL database. And that's going to go ahead and initialize. And we can see that happening up here. So what's happening here is we're initializing this connection to that server, and then we'll basically restore the database on that server. So it'll initialize, and then it'll seed and give us a percentage. So while that's happening, we can go ahead and we can select another region. So I'm going to select Southeast Asia. And again, I just have to specify the server over there I want to use. And note that these servers I'm deploying are going to be readable only. So they're going to be readable secondaries. They have different connection strings. So we can see now this one's seeding. It's very small, but it's a 0%. And then we're initializing a connection over here in Southeast Asia. So now in order to use these as readable secondaries in SSMS, I just have to specify those servers. So again, it's a little different. So I'll show you. I can specify this server, which I called Central, yeah. So it's in Central US. So I'm having to use a different connection string to get connected. Let's just make sure I'm not good. So you can see that it's here, and I don't have any databases in it right now. But if I go ahead and refresh this, I'll see that the AdventureWorks general purpose database has now been restored there, and I can use it like a readable secondary. Same thing for Southeast Asia, just a different connection string. So that's one of the big differences, is that if I do force a failover, I'm going to have to update the connection string. So that's a big difference between this and managed instance or auto failover groups in SQL Database. So we can see they're both there, and I can start using them. It looks like this one's not quite ready, but the Central US one is readable. And now it's ready. So again, just another thing that becomes very easy to do once you're running in a PaaS type of platform, and this one specifically only in Azure and in Azure SQL Database. Okay, so I'm seeing a lot of questions, so I'm gonna take a second to try to look at them.
I can read this to you, Anna. So as a SQL developer, what monitoring tools should we be aware of if we are in Azure production?
Yeah, that's a great question. So what monitoring tools? There are a lot of monitoring tools available. Actually, the Azure backbone supports this thing called Azure Monitor, and we're currently working on, there's a lot that's in there today, and there are a lot of different things you can look at compared to SQL Server. And this is actually a really great question, and it's a great lead-in and pitch for the thing that Bob and I have been working on, which is the Azure SQL Workshop, because we really dive deep into some of the monitoring aspects with regards to performance, with regards to security, and with regards to availability. I think it's a little outside of the scope of this session, but what I will do is I will share those resources with you at the end, and then you can always contact me offline if you have specific questions. And since you asked, I think I'm allowed to share that we are working on a really cool addition to this monitoring suite that is available on Azure today. And I hope that's available soon, but that would be across the Azure SQL family, so including VMs. So that's something to look out for, but something that's not quite there yet. But great question. And then the other question is, does geo-replication come with an extra cost other than what we pay for Azure SQL DB? That's a good question. You're gonna pay for that second database. I believe it has the same cost as the original database, but what you get from it is, now you have a database in another region. And I'll talk about some of the ways that you can cost save when you're talking about deploying these type of solutions in Azure today. And related to that, it kind of depends what you're trying to do with the geo-replicated database, because it might be something that business critical or another service tier can give to you without having to be in another region. So just stay tuned on that one. And there's a few other ones. One about SCOM monitoring. Again, I'm going to save that one just because I think it's a little bit out of the scope of this talk. One question is, why did Microsoft name it Azure? What does it mean? And that I'm not exactly sure the answer to that, but I'm sure we could Google it. I know that Azure means like blue sky or something like that, so it might be related to that in the cloud. A lot of questions coming in now. Okay, I'll take a few more before we go forward. It says, can I choose the version of SQL from Lamore? Thanks, Lamore. That's a great question. If you're in a SQL Server in a virtual machine, yes, you can choose the exact version of your SQL Server as well as your OS. If you're in managed instance or SQL database, you don't get to choose your version. Like I mentioned, it's kind of versionless, so you just kind of get where we're at. But what you do get to choose is your DB compat. So if a certain number hasn't been tested yet or a compatibility level, you can stay with your version, your DB compat level, and move to SQL database or managed instance, and we'll support you in that. And we won't break you. So hopefully that helps answer that question. Will you also talk about licensing and cost from Nandini? A little bit, but just relatively, not really. but I can point you to some things. Okay, let's see.
Anna, I just shared a link about licensing.
Okay, thanks.
That is Amit talking about licensing.
Okay. Let's see. Okay, here's the next one, sorry. If backup will happen, then any SQL query, then we can track the backups. I'm not exactly sure what that question is asking, but you can set up automated backups to be done. They're set up automatically for you, but you can set up the exact schedule that you would like. And I'll take one more question from Balaji. It says, will we be alerted when the failover happens from primary to secondary replica if we use log analytics? And I'm assuming you're referring to auto failover groups. So when a failover happens between the primary and the failover group, can we tell from log analytics? Today, if it happens automatically, you might not be able to tell. There's some abstraction that we do on our side. There are some clues, but there are different reasons that we might have to fail you over for things. And sometimes you'll just see like that it was unavailable for a few moments, but you won't necessarily see if a failover is what happened. But with regards to your auto failover group, you should be able to see which server you're running on, so you can see that. Okay, I think that's enough questions for now, but I'll let Ree start to tackle them, and then we'll kind of come back to this in a little bit. Hopefully those were acceptable answers for you all. Okay, so we talked about Azure SQL or SQL Server and Azure VM. We talked about Azure SQL Managed Instance, which is this idea of a managed SQL Server. It is a PaaS service, and we talked about Azure SQL Database, which kind of just gives you a database and a lot of capabilities, also a PaaS service. So I put the PaaS services up on the screen just to kind of summarize what we've talked about so far and mention the two pools options. Now, elastic pools I mentioned briefly because if you have a lot of databases, then using elastic pools can be great because you can resource share between them. They can also be multi-tenanted, and this can help with cost management as well as just overall management because there's a nice way to manage over that whole pool. And all of the databases in an elastic pool are SQL databases, so they're you get a lot of those benefits that are there as well. Now, when we talk about instance pools, which is something maybe you haven't heard as much about, these are currently in public preview. What an instance pool, well, let me back up. So with Azure SQL Managed Instance, when you deploy this, it actually can take some time to deploy. If you've ever deployed a managed instance before, you know what I'm talking about. It can take a few hours to deploy this thing. And the reason is because we're deploying a whole ring for you, essentially. And that's what gives it kind of the enhanced security that you're seeing. Now that takes time. And a lot of people have said, okay, this makes migrating difficult. This makes moving or spinning this thing up take a really long time. So what we came up with is this thing called instance pools. So what this allows you to do is basically pre-provision the compute resources for a pool. So you would deploy a pool, and that would take a little bit of time, but then deploying managed instances into the pool takes significantly less time. So this can help for making a smooth migration. One of the other things that this unlocks for you is that you can have smaller instances than you can have in a regular managed instance. So as small as 2 vCore managed instance can sit inside a pool because you're pre-provisioning a certain amount of resources, so you can have smaller managed instances. Again, this is in public preview, but it's been a really interesting thing, I think, and it's helped a lot of customers kind of enable smooth and efficient migration to Azure. Now, once you kind of land on an option here, right? So we've been talking about deployment options. The next thing is service tiers. And service tiers are different between each of these. So I wanted to kind of drill down into managed instance first, and then drill down into SQL Database and start talking about these different service tiers and why you might choose one over the other. So we're going to start with managed instance. And I'm not going to go over the architectures here. I think it's a little beyond the scope of this session, but I do have the architecture slides in the appendix. So if at the end you have questions about it, we can pull it up. And if there's time, we can go through them. So there are two options in managed instance. So managed instance is in many ways a little bit more simple than SQL Database, just because there's a lot of options in SQL Database. But in managed instance, you have two options: general purpose or business critical. And what we found is that general purpose is great for most of our customers and for most business workloads. So if you're looking to move to Azure, my recommendation would be to start in general purpose. Whether you're in SQL Database or managed instance, start with general purpose. Now, business critical is really for those business critical workloads. You know, you need low latency, fast recovery. Maybe you need a readable secondary off the start. This is going to be a good option for you. Now, these both are hosted using the vCore model, which allows you to independently scale your compute and storage resources. This is your only option, so it's an easy choice to make. And then just a little bit about how these are structured, why business critical is so much faster or different from general purpose. And general purpose has your TempDB on local SSD, but your data and files are stored in remote storage. Whereas business critical, everything is located on your local SSD, making it a bit faster than going to remote storage. So when you think about IOPS or IOs per second, I say IOPS plus plus, because basically just to say you're going to get better performance here in business critical than you are in general purpose. And then this is another interesting one. When you deploy general purpose, you get your primary, and that's the only one you can read on. And we're doing automatic backups and that sort of thing. But you don't have secondaries per se or readable secondaries unless you set those up yourself with something like geo-replication or auto failover groups. Now with business critical, what we basically do, and I think you're probably all familiar with this terminology being SQL Server gurus, but what we do is we basically spin up an availability group. So we have a primary and we have 3 secondaries, and we actually allow you to read from one of the secondaries. So right off the bat, you're able to have a primary and a readable secondary. And then the other thing that I wanted to mention is cost. Again, I'm doing everything relative here. The exact costs are going to depend on your region, your Azure deal, all sorts of things that are not something I work on or have lots of insight into. But from a cost perspective, business critical is going to be significantly more expensive than general purpose. And if you look at all the things you get with business critical, hopefully you can kind of understand why that it's more expensive. And one other thing you get in business critical that you can't get in general purpose is in-memory OLTP. So this is only available in the business critical tier. Now, I wanted to show you one interesting example. Again, this is one of these new demos, so we'll see how it goes. But how you can get faster failovers with business critical than with a general purpose database. And this applies to managed instance and SQL database because business critical and general purpose are available in both. So let's see what this tab is. So what we're going to do, just give this a second to load. This is something else. Okay. What we're going to do is we're going to initiate a failover, just basically force a failover to occur. So in general purpose, we're just going to pull down, force the primary to go down and another one to be spun up. And in business critical, we're going to do kind of the same thing. And I'll show you all how you can do this so you can see how long it takes in your environment. Now this is an interesting demo that I set up. I hope you find it interesting. So what I'm doing here is I have an integrated terminal in Azure Data Studio, and I also have a PowerShell notebook. And what I'm going to do is I'm going to use OStress, which is probably a tool many of you are familiar with, or at least you've seen in lots of demos. And what I'm going to use OStress for is to basically just do a simple select statement from that general purpose database. And I'm just running one thread, but 50,000 times. So I just wanted to just keep trying to hit the server and see if we can access it. So I can run this in the terminal, and what we're going to see is we're just seeing that it is able to successfully run. And it doesn't look like it's updating, but it's updating very quickly. You can see it flash every now and then. Okay, so now we have this thing running to show us, okay, connections are able to be made. Now, what we're going to do is we're going to use PowerShell to invoke a failover. So this isn't using failover groups or geo-replication or anything like that. We're just going to say, for whatever reason, some sort of failover is going to happen. So maybe Azure detects something's wrong and needs to fail you over to a different node or something like that. We're just going to simulate that with this command. And one thing to note is you can only do this once every 30 minutes. So if you are testing this or demoing it, be careful. And hopefully I've been careful enough. Okay, so then what I'm going to do is I'm going to time it. So what I'm going to do is I'm going to hit play, and that's going to invoke this failover. And I'm going to start my timer. And you'll eventually see this become unavailable. So it will look unlike this. You probably won't be able to make out the message, but it's basically going to say, cannot connect to server. So when it's unavailable as the failover is happening. Once we start to see this 8:47 again, then I'll split it and pause the timer, and that will be our time for how long a general purpose database takes to fail over. Hopefully that makes sense. Okay, let's try it. Okay, so we see that this is running. We see we no longer have connection. So we're seeing we're not able to connect as this failover is happening. So our database is unavailable at this point. So this usually takes around 30 or so seconds as this new database is being spun up and the data is being moved over. A lot of questions coming in. I will take a look at them after this demo, I promise. So now it's back, so I'm gonna pause it. So we see it took about 30 seconds. We see that. I'm also gonna start this timer and split it and pause it again, just so we have a new timer going for our next session. So now what we're gonna try to do is we're gonna do the same test. So I'm gonna stop this OStress workload. We're gonna do the same test, except now for a business critical database. So these are the exact same database. One is AdventureWorks with GP tacked onto the end, and one is AdventureWorks with BC tacked onto the end. And we're gonna see how much faster a business critical database does the same thing. So I'm gonna go ahead and get this set up. And then we'll run the workload. So we're running the exact same workload, just selecting the count from that table, one thread 50,000 times. So we see it's starting to run over here. Same result as before, but now we're connecting to that business critical database. Okay, again, I'm gonna push play, then I'm gonna start this timer, noting that I'm not super fast, so it's gonna have an extra second on it, so we can just subtract a second later. And we'll see how long this one takes. So I'm gonna hit start, then I'm gonna hit start. And we see it becomes unavailable, and almost immediately it becomes unavailable. And we'll see how long it takes to become available again. So there, now it's back to being available. So we can subtract a second. Actually, it works out pretty nicely. So it took 15 seconds in this configuration that I have for it to fail over with Azure SQL Database running business critical. And it took almost 31 seconds for it to fail over. No, that's not the time it's unavailable. That's the time for the complete failover. So there was some time at the beginning where you could still connect before the failover started, but it's still, you know, it's pretty significant, the difference in availability you get from general purpose to business critical. And the reason why it's so much faster, one of the reasons is that because we have an availability group, it's very easy for us to just point you to another one of your secondaries, and then in the meantime spin up another secondary and seed another secondary. So hopefully that was interesting. I will take a look at the questions.
So a few of these questions, Anna, while you go to look, it's someone, they're asking their question and adding details in several different lines, so it looks like there's more than it is. But Anshul asks, do we have any control over memory allocation for Azure SQL Database and managed instance? And adds that they have service tiers classified for managed instance based on CPU count only, and there's no details about the memory allocation. So how can they identify the memory allocation for that?
Yeah, great question. And the memory allocation is actually explained in the service limits part of the documentation. Sometimes it's hard to find these different things in the documentation, but that's a great question because CPU and memory are kind of packaged together in a vCore, so you can see what you get with each tier. And I can share that link and make sure that's available. Or maybe Ree, if she's not drowning in questions, can share that link with resource limits. Okay. How many databases can we create in a single server in Azure? Okay, so that's interesting. That is one reason that you might consider using SQL Server and a VM over SQL database or SQL managed instance. And the reason is you can't have unlimited databases associated with one logical server in the case of SQL database. I think the limit is 100 databases. I would have to double check that, but there is a limit. So definitely a good call out to be aware of when you're looking at moving to PaaS versus IaaS is how many databases.
I think the limit there is more about resources. So there's a limit to the number of resources that the server can have. So depending on how you set up those databases, there is a cap, but it will. I think it will change based on how you provision them. It's gray to me. I'd love to say I understood it, but I don't completely.
Yeah. So whoever asked that question, if you want to clarify it, we can try to answer offline or later or something like that. And then. How many databases group together in a single availability group max in Azure? I think you're talking about business critical, and our deployment for that is really we deploy 4, and 1 is the primary. You get 3 secondaries, and 1 of those can be used as a readable. That changes in the hyperscale tier, which we'll talk about soon, so hopefully that will help. I have 25,000 databases. How do I implement always on implementation? I'm going to ask that you send me an email because I want you to talk to the team about that. That'll be good. They'll like that. Okay, let's see. In SQL MI, does the size of the database and how busy it is matter on failover duration? I lost the question. V. Kingston. To a certain extent, yes. It's going to depend on what tier you're in, because, for example, if you're in business critical, it's much easier because it's just kind of moving the tiers. But for general purpose, I believe it can take a little bit longer, and that size of data operation is another thing that's going to come up soon. So I'm glad you asked it. We'll be able to touch back on it. Awesome, great questions. I'm glad you guys are so engaged for a Friday afternoon. It's helping me stay awake because here it is 7 a.m. Okay, hopefully maybe you've seen the sun has come up since we've started talking, which is wonderful. Okay, so now we're going to shift. We talked about managed instance and how you have the general purpose and business critical tier available in managed instance. And now we're going to shift to talking about single database or SQL database and the different options you have. Now, if you remember, in managed instance, you only had the option to do the vCore model. Managed instance is much more recent product, so it was kind of after the time of DTU. But when we first went with SQL Database, we had this DTU model available as well. And it's still available today in the SQL Database or single database model. And what this does is it gives you a packaged bundle, per se, of storage and compute. So an S1 has a certain amount of storage and compute, and you just kind of scale linearly. Now, this was to offer what you see there, simplicity of choice. But what we've seen is like many customers want to be able to scale independently their compute and storage. And that's what the vCore model allows you to do. So you have this choice. You don't have it in managed instance, you have it here. But Microsoft's recommendation is to go with the vCore model. And besides being able to get more of what it is that you actually need, one of the big or two big benefits here is that the vCore model is the only way you can start to get things like Azure Hybrid Benefit, which can provide really big cost savings if you have existing SQL Server licenses, as well as reserved capacity. Now, reserved capacity is kind of interesting because what you do is you basically pay for a certain amount of resources in advance, but with that comes a pretty significant discount. But both of these cost-saving measures are only going to be available in the vCore model. So just something to think about it. So today, I'm just going to focus on the vCore model, just because, again, like this is kind of the recommended model we go with, but a lot of the things that I talk about in the vCore model will apply to DTU as well. Okay, so we're going to talk about service tiers. Now, pretty similar to managed instance, we have general purpose and business critical. A few differences, which we'll talk about. And then we also have the hyperscale tier, which you've probably been hearing a lot about, maybe a lot of hype, which just makes me laugh when people like Sanjay Mishra say it, but I love it. There's a third tier, basically. So you've heard a lot about hyperscale, but now you know it's actually a service tier within the deployment option of SQL Database. So it's not available in managed instance today. It's something we're working on, but it's not available today. And the same statements kind of apply with regards to scenarios. You know, most of our customers, most of you all are going to be just fine on general purpose, and that's going to be the most cost efficient thing for you to do. But if you have really stringent requirements as far as latency or recovery goes, business critical is still going to be the way to go. It's going to come with that penny, you know, it's going to come with that extra cost, but it's worth it to many of our customers that have those specific scenarios that need that. And then with hyperscale, you're going to get a few things. You're going to be able to get essentially unlimited storage, which we have said on stage, and people like Bill Gates and Satya have talked about. So they're very excited about this feature. Actually, we support up to 100 terabytes, but really that's just a theoretical limit. There's no reason why we couldn't go higher than that. Actually, on stage last July, we had, I think it was like a 200 terabyte database in Hyperscale. So definitely some options there. So let's just go through this again. So we talked about how general purpose was leveraging remote storage for the data and the files. And that's the same here in SQL Database, and business critical is the same. It's leveraging the local storage, local SSD, and you get that availability group type of thing. And with hyperscale, it's a completely different architecture. Again, I'm not going to go into that architecture today, but I definitely recommend you go and check it out because it's really interesting. I just like love going to these hyperscale sessions and my brain melting every time about how we got this working, how we re-architected SQL Server. This is very interesting. Not going to go too deep in it today, so sorry. From an I/O perspective, again, I'm not putting exact numbers here. I'm just using relative comparisons. So when you're comparing one over the other, you're still going to get the best with business critical. Depending on your workload in hyperscale, you can get pretty good I/O per second. It's just going to depend. And then general purpose is probably going to be, you know, not as good as the other two tiers. But I would say hyperscale is going to fall somewhere between general purpose and business critical, depending on your workload. One of the interesting things here is, again, with general purpose and business critical, same as managed instance. General purpose, you get your primary, that's kind of it. And with business critical, you're going to get an availability group, basically. So you're going to get a primary, 3 secondaries, and you can use one of those as a readable secondary. Now with hyperscale, what's interesting is you can have between 0 and 4 readable secondaries. You know, lots of interesting stuff around how we make this work and how we make it so this doesn't increase latency greatly or commit time. But this is an option in hyperscale, and there is some pricing information about these readable secondaries. It's different from deploying a whole new database, but those details will come in the resources. From a cost perspective, like I said, business critical gives you the best performance, and there's a cost associated with that. Similar with hyperscale, there's a slightly more expensive cost than general purpose associated with this new architecture and these new capabilities that come with hyperscale, as well as that unlimited storage. Now, a few extras that I wanted to throw in for business critical is this idea of serverless compute. Now, this only falls under SQL Database in the general purpose tier. So that's something to remember. It's very specific today to SQL Database and general purpose. And what serverless does is we've separated the compute from the storage completely, and we can actually, for certain workloads, and we'll talk about this more, we can only charge you for storage if you're not using any compute. So this can be a great way to cost size if it fits your scenario. And that's the big, like, if it fits your scenario. And we'll talk about that scenario so you know when to choose serverless. Again, business critical is the only option between all three of these where you can get that in-memory OLTP. So if your application is leveraging that, or you want to leverage that, or it makes sense for your use case, this is going to be the only place that you're going to get it. And then finally, in hyperscale, you get this unlimited storage, which I already talked about. Okay, so that's kind of your overview of the service tiers. I want to show you, I think I have a demo now. Yeah, so I want to show you something in hyperscale, and I'm not going to show you like a huge database. I didn't have time to get that all set up. But what I do want to show you is something really cool. I think probably a lot of you attended David Mari's session on earlier today, but I got some of this from him. Let me just pull it up so you can see it. This is a mess. Here we go. But basically, this code that I'm going to use, this sample I'm going to use that I'm going to share with you all, was built by Davide, and he basically was able to create an auto scale function in leveraging Azure Functions. So leveraging kind of the power of the cloud, he was able to create this function that can actually monitor what the average CPU utilization is, and then if it hits a certain limit, actually request a higher slow. So slow, to break down that term, that's service level objective. So it's another term, just, you know, lots of terms that we use to describe kind of the service tier and the number of vCores that you're using. But basically this app will monitor that, and if it sees that the CPU is high for a certain amount of time, it will go ahead and request a higher slow. So if I run this now, this is just monitoring what's happening, and I think I have some time, so I'm going to break this down, what's happening here. So this inserted at tells us what time the reading was taken. So what you'll notice is my function is set up to kind of trigger every 10 seconds. So every 10 seconds, and I kind of made this low for demo purposes. For your workload, it might be, you know, every 30 seconds, every minute, something like that. And then we have the current slow. So this means hyperscale Gen 5 hardware. We'll talk about hardware just briefly. And then this is the important number, this 2. So right now it's a 2 vCore solution, and this can scale from 2 to 80 depending on your hardware, but let's just say 2 to 80, and then it says the requested slow. So the requested slow is the same, so nothing is really happening in the background. This is the raw JSON, and then I'm going to make this smaller. Okay, and then what we're going to see is we're going to see the average CPU percent for that 10-second interval. And then we're using ARIMA modeling, so basically a moving average. So we're taking, for me, I set the data points as 3, again, just for demo purposes. You might want to have a higher number of samples before you decide to upsize. But basically, this is going to take the moving average as the last 3 points in that service tier, so in 2 vCore or 4 vCore, and display that here. And if this number gets above 70%, I think that's the threshold I set, it will go ahead and trigger that upload. So what I did is I created an OStress workload. Again, something you all are very familiar with. Basically, it calls that server, the server that has my Hyperscale database, and then the database is the Hyperscale one. I took out the password here to show you guys, but basically I'm running 10 threads 200 times, and I can show you all the query. It's just a query to create a workload. So it's just nothing really interesting about this query. Okay, so what I'm going to do is I'm going to stop this. And okay, so I'm going to, I put that OStress command in a load test script. I'm going to kick off that script. So now this script is running. So we should start to see a workload appear here. And this, this specific workload I created takes about 4 minutes to run. So while it's getting spun up, I thought I would show you this Azure function. And this was really easy for me to set up. Davide did a really good job sharing the code, and there's a blog post as well that you can read to see how to set it up and how it worked and the results he got. But this is my autoscale function. This is an app service, and within it, it's a function app. So it's an app service, but specifically a function app. So if I go into the functions, I have 2 functions. I actually took the autoscaler code that Davide published, and I also made one for business critical. So the comment here is that this can apply to business critical or hyperscale, or you could create a function for general purpose as well to kind of autoscale as needed. If I go into the autoscale hyperscale, I can go into monitor. And this is basically just going to tell me things about how many times it's run, the errors that have happened as I was setting this up. And then we can click in and see some details about what happened when that trigger was run. So right now it says it was triggered because of the timer, because I set it up to run every 10 seconds, and it succeeded or failed. So nothing else really is happening at this point. One thing to note is this is about this is a few minutes behind, so so sometimes it won't catch it at exact time what's happening real time. Okay, so let's try this, because this will be real time. Okay, so I might have hit it at the perfectly worst time. We can always shift if that happens. Yeah, so what happened is I ran it as a scale was happening, so it was momentarily unavailable. So we should be able to run it now and see. So let's take a look at what's changed. And I know there's a lot on this screen, so just try to follow where I highlight, and hopefully that helps. Okay, so we were running 2 vCore. You're just going to want to look at that 2 number, 2 vCore. And then when the workload started, so I think the workload started here, we can see the average CPU shot up to 85%, leaving our moving average, so the average between these 3 points, as 28%. So nothing was triggered because the moving average wasn't that high, and it didn't meet my threshold that my function specified. But very quickly, if we go 20 seconds later, our moving average is now at 60%, And since the moving average goes up to above 70% in the next function trigger, we're going to request 4 vcores. So that's what happened. And then we requested 4 vcores. 4 vcores, we see we're running at 99% CPU. And once we hit, oh, it looks like my workload completed. But once we hit this Gen 4, we're not going to request a new slow because the moving average starts over. So our moving average turns to 0. This is the momentary while it's unavailable. And now I refresh again so I can see it was unavailable for these 2 tries for about 10 or 15 seconds. And then we got to Gen 5 4 vcores. And again, 10 seconds later, our moving average was 55. And 20 seconds later, we triggered another increase because our moving average of CPU was above 70% again. So this isn't a built-in feature in Azure SQL Database, but this was a really easy thing that I was able to set up so that I can scale up and scale down my hyperscale or business critical or general purpose databases. Now, why am I showing you this in hyperscale? Might be what you're asking. And the reason is, and see now what you see is that the workload has completed. And so it's scaling back down because the CPU usage has gone back down. But the reason I'm showing you this in Hyperscale is because Hyperscale has this really interesting property where they've separated a lot of the things. So they've separated the compute from any of the page servers. So what they're able to do is scale up and down independent of size. So it's not a size of data operation. So if my database, if this hyperscale database happened to be like 15 terabytes, I could still expect this change in slow to happen over the same amount of time. So if we take a look, it looks like to get from Gen 6 to Gen 6 was 1, 2, 3, 4, 5, 6. So 6 times 10 seconds, about a minute. So even if you had a 15 terabyte or 50 terabyte, you're looking at scaling up in about a minute or so. So that's huge and very different from the general purpose and business critical architectures where some reseeding has to happen. So that's one reason why you might consider the hyperscale tier. Apart from just being able to have a lot of data, there's a lot of things that we've added so that these size of data operations go much more smoothly. Again, I'm going to share all this code. It was pretty easy to set up, and you guys can try it out. Okay. And we have no questions. Ree, you are killing it. Thank you so much. Okay, so I talked about scaling in the sense that we go from different service tiers in a matter of minutes, and Hyperscale can do that regardless of size. So I want to shift a little bit. This is related, but slightly different. So let's think of a specific scenario. Let's say I have a line of business application. So maybe it's an expense reporting app, and maybe that was a bad example at given this time, but let's say people are traveling and it's an expense reporting app, and a lot of people don't use this expense reporting app except near the end of the month or at the after a big internal conference. And so this app really doesn't see a lot of activity necessarily. And when it does see activity, it can be very unpredictable. So it might see a lot of activity at the end of the month, or it might see a lot of activity after a big conference. And you have to make this decision of, okay, do I over provision in order to get the performance that I need when I need it? Or do I under provision and eat the costs associated with that? This is where serverless, and this is available in SQL Database, the general purpose tier, has really changed the game, because what you can do is you can set the number of minimum vcores and the number of maximum vcores. So in this case, I set 1 and 4. And if we just walk through a day with this sample app, in the morning, like a few people start connecting and maybe logging some expense reports. So this app is being used. So we're being billed at that minimum vCore limit. And this vCore is based on the max of CPU or memory requested. Now, people start to use this and it goes up pretty high and it's getting hit pretty hard. What happens in that range of 1 to 4 is we're scaling on a per second basis. We're able to scale the compute to exactly what you need at the second that you need it. So this is pretty incredible. You know, compared to Hyperscale, where it's great, there was some configuration and there's some time that it takes. But with serverless, we're able to scale on a per second basis. And then the day goes on, we scale, you know, go up and down between our limits. And as people start going home and not using the app anymore, we reach a period of inactivity where no one tries to hit that server. Now, if we set that activity to be like an hour or two, what will happen is we'll actually separate the compute from the storage. So we're going to actually remove the SQL Server. Actually, we're going to shut SQL Server down, basically. And at that point, you're not paying anything for compute. You're only going to pay for storage, which is very low cost. Now, then in the morning, when people start logging in again, you'll see some performance hit because you're starting with a cold cache, because you're just basically restarting, reconnecting SQL Server and having to start cold. So if your workload can handle that, then you're able to potentially save on a lot of costs. And they've done some really interesting things around cache reclamation and memory reclamation to make this work. So this is a really interesting thing that we've been dealing with, and especially in this serverless type of landscape. If it makes sense for your scenario, it can be really great. Now, related to serverless, I often get the question, okay, you said elastic pools are great for resource sharing and optimizing costs. So why don't I just turn all my elastic pool databases into serverless databases? For the most part, it's going to be better from a management perspective for sure, because you're managing a whole pool as opposed to, you know, hundreds of serverless databases. It might be better to go with the elastic pools route. But again, it's going to depend on your scenario. And I just wanted to share one example of someone using elastic pools, and that's Paychex. And I think they have like 600,000 customers just in the US, and they manage their payroll and other things. And they're all running on elastic pools. So for that type of scale, that's what elastic pools is really made for. So it's probably going to be a better experience and better cost performance than a serverless type of database. Okay, that was a lot of options. I'm just going to take a breath for a second. I'm going to take a little break and look at these questions. I see Salil said, when you talked about hyperscale, there must be a limit based on cost, which we can set. If you're talking about the auto scaling demo that I set up, you can go in and change the limits that you scale between for the number of vCores 100%. You have complete control over that. I just set mine up to go all the way to the top, you know, incrementally. But yes, you could deploy that app to meet your business scenario. And V Kingston said, looking forward to see your scripts and scenario and try this. That's awesome. We're, you know, looking forward to hearing how it goes, and certainly let me know if I can help. And okay, so now we're back. Take a breath. You've just seen a lot of stuff. I just got one thing to show you left, and it's hardware. And this is a relatively easy decision. I'm just going to animate all of this. Really, the choice you have today is mostly just choose Gen 5. We used to also have Gen 4, and as time progresses and technology and hardware evolves, of course, there's going to be other generations. Gen 4 is still available, but it's kind of being phased out in 2020. Gen 5 is like our main go-to option. Serverless is only available in Gen 5. So again, fortunately, this is a relatively easy choice with Gen 5. However, like I said, going forward, there will be new options, I'm sure, as hardware evolves. And even today, we have some options in preview, depending on your workload for hardware. So I just want to throw that in there. I know we were going to talk about service tiers and deployment options, but I also just wanted to throw that in there. Okay, I have one last demo for you. I think I'm almost out of time, actually. But we did answer a lot of questions in the middle, so hopefully, and I'll share my info, so you can always ask me more questions later. Okay, so I want to show you what we did today. I'm going to disconnect this. So we talked about SQL VM, SQL MI, and we talked about SQL Database. And you can see kind of the differences just taking a look at this. I won't go too much into this because of time. But what you see with SQL Server and a virtual machine, we get it all. It's just SQL Server. This should look just like any other SQL Server. When we move to manage instance, we get almost all of it. And you can compare some of these things like Polybase isn't available here, but you get all the system databases. You're still managing the server. And then finally, we have a single database, and you don't get all the things that you get with a server because you're just responsible for the database. And the last thing before I go way over time is I wanted to show you this view of how you can help yourself and help your team understand which option is best for you. There's this thing called Azure SQL. You can now search for it. And they basically give you this unified experience that will walk you through the different options that are available. Okay, I know we're at time. I want to, we talked about all these options. I hope you feel like you learned something today about VMs, MI, database, and as well as the different service tiers, general purpose, business critical, hyperscale. I hope you go and try all of these apps and try these demos. And I want to thank our partners, of course, and thanks to Amit and the team for all that they've done to get this set up. And thanks for sticking with me through the end of the day. And everything you need is on this page, all my links, everything. And I'm going to stop talking now. Thank you so much. And back to you, Ree.
Awesome, Anna. Thank you. Actually, I learned a lot, and people asked some fantastic questions, and a few times I would have to go Google the link because I knew I had the information somewhere, and there's no way I was going to be able to just explain all of that in the question. So I would just pop the link in. Here's the documentation. Here's the FAQs.
Yeah. It's a lot.
Yeah, it can be overwhelming. This is a really, really good start, though. A really good basic lesson on everything that we have and what we build. And then you did a couple of little deep dive things that weren't beginner at all. So fantastic job.
Thanks, Ree.
And there you are, Amit. I see you.
Yes, and Anna's the details were there. So please connect with her and continue your discussions beyond the session. And please, friends, give feedback for every session that you have attended, and including this last one. Anna, thank you. Wonderful presentation, and a good. From the Microsoft perspective, from that real world perspective that you brought in, I think it was great. Thank you so much for your time today.
Thanks for having me. It's an honor.